One quiet summer afternoon, Arjun was exploring his grandfather's old attic when something unusual caught his eye.
Curious, Arjun picked up the box and gave it a gentle shake. Something was moving inside, but he couldn't see what it was.
Arjun's imagination ran wild. Was it a key, a diamond, a coin, or something completely different hidden inside the box?
What if all these possibilities somehow existed at the same time, waiting for someone to discover the truth? As the box glowed brighter and brighter, something incredible happened. A doorway opened to a world far stranger than anything Arjun had ever imagined. On the other side, Arjun found himself in a mysterious quantum world. Here, particles behaved in ways that seemed impossible.
To Arjun's surprise, the particle didn't stay in just one place. It seemed to exist in several places at the same time.
This strange behavior is called superposition. Instead of choosing just one state, a quantum particle can exist in many possible states at the same time. Traditional computers use bits to store information. A bit can only be one of two values, 0 or 1.
But in the quantum world, information is stored differently. Instead of bits, quantum computers use qubits. Unlike a classical bit, which must be either 0 or 1, a qubit can exist in a combination of both states at the same time. Before we measure a qubit, we don't know exactly whether it will be 0 or 1. Instead, it exists as a collection of possibilities, each with its own probability.
Arjun wondered, if a qubit can exist in many possibilities at once, how can we ever know its actual value?
As the measurement continues, the qubit can no longer remain in many possibilities at once. Its quantum state begins to collapse into a single outcome. The moment measurement begins, the quantum system starts to change. Observation is no longer passive, it directly affects the qubit's state. To uncover the qubit's value, scientists perform a measurement. Measurement is the process of observing a quantum state and extracting information from it. At the end of the measurement, all other possibilities disappear. Only one definite result remains.
But why did the result become 1 instead of 0? Before measurement, each possible outcome, measurement reveals one outcome according to those probabilities.
By collecting many measurements, scientists can uncover the probabilities hidden inside a quantum state. Patterns emerge even when individual outcomes seem unpredictable.
To understand measurement more easily, imagine a spinning coin. While the coin is spinning, it can be difficult to know whether it will land on heads or tails. We only know the possible outcomes. But the moment the coin stops, we see only one result. In the same way, a quantum measurement produces one definite outcome from many possibilities. Quantum computers rely on measurement to obtain useful answers. Without measurement, the results of a quantum computation would remain hidden within quantum possibilities.
Arjun's journey taught him that quantum measurement is the bridge between possibility and reality, and that is why measurement is one of the most important ideas in quantum computing.